Okay, where were we lost last? Can anyone just give me a quick hint and I can start right from there? Were we all there till the concept of oak? Oh wow, the set-top box. Okay, so basically, James Gosling, he thought of designing this new application for set-top boxes. Okay, now the reason being there was a variety of set-top boxes that were provided in the market, and ultimately all set-top boxes needed to do one single thing, which was decode the signal. So he generated a platform for set-top boxes which could descramble these signals. Now, if you realize, his primary objective of doing that for the set-top boxes was based on the embedded system architecture. So basically, he wanted an application which would run on any set-top box that would be capable of decoding signals and working around. So when he changes from set-top box A to set-top box B, the application should not get modified. In 1993, he successfully generated this new language. Now, while he was talking about generating this new language, he had two options in front of him. A, either I create a brand new language and go through all the hardship that has been taking place over the past years, or B, I use something which is already existing. So he decided to completely pull out the syntax of the language C, that is, use the syntax of C for this particular new language that he's developing, and to use the object-oriented principles from the language C++. So making a combination of syntax of C and the object-oriented principles from C++, he went ahead creating this particular new language, which eventually he wanted to provide with a beautiful name. Now, the best thing that this guy could think of as a name for the operating system, name for the new platform was the language name as Oak. A pretty silly reason for that. This guy had on one Valentine Day finally fallen in love with an oak tree which was outside his office. Now, every time he used to think of this new programming language or work on the programming language, he went ahead looking at that particular tree. Probably that tree gave him a lot of inspiration with some logic of his, and that's exactly why he decided to name the language as Oak. Some microsystems, however, refused this particular language name since there was already a language pre-existing in the market called as Oak. Now, the other thing my friend really liked was coffee, and coffee also has another name for itself called as Java. So you'll see a lot of malls even in Pune which run a Java boutique, which is basically a cafe, coffee kind of, or a coffee cafe, whatever you call it as. The first official version of Java, which was introduced as the JDK 1.0, was introduced in the market in 1994. This was the very first time when a language was introduced in the market which guaranteed the principle of platform independence. Are we all okay till this particular point? Anyone would like to ask any questions before I take you further from here? About Prerna, Aditya, Ankush, Akshay. Great. Now, Java works on a very simple concept. Any code that is being defined in Java is going to be compiled in a Java specific format. Okay, now what do I exactly mean by this? Now, generally, whenever we talk about any C or C++ program which is being compiled by us, this compilation results into an obj file. The obj file is nothing but a machine dependent code. It is nothing but a binary format, which is specific to the underlying platform. So whether I'm talking about C, whether I'm talking about most of the languages, whatever you are well known, you will realize that all these languages will always compile ultimately into a binary format. What does Java exactly do? Java goes ahead and compiles all its code into something what we call as a class file, which also has another term called as the bytecode. This bytecode is not based on any platform. It does not work on any kind of platform, or it is not designed for any platform. It is just simple bytecode, which is in turn a stack-based code. Now, when I'm talking about stack-based code, which means it is very similar to an assembly language code. Okay, it's very similar to an assembly language code which has been created. So all your Java files, once they are compiled, they will be converted into something what is called as a bytecode, which is a stack-based code, which is similar to assembly language. A bytecode, because it's not in the binary format, it cannot be executed on the underlying platform. So what he needs to execute on the underlying platform is a VM, a virtual machine, someone who can understand that bytecode. Okay, he requires someone who has the capabilities of understanding the bytecode, and that's exactly where your virtual machine comes into the picture. Now, what we have as a scenario is something like this: you have the hardware. The hardware runs with the support of the OS. On top of the OS is another layer called as the JVM, and on top of this JVM is where your bytecode or your Java app is going to be executed. So if you notice, it is a JVM which is now completing the link between the OS and the JVM. So the bridging is being done with the help of the Java virtual machine. Okay? So all your Java apps which form in the which generate an output in the form of the bytecode will be given to the JVM. So any communication that the Java app needs to do will go to the JVM. The JVM will further communicate that with the OS. The OS will further communicate with the hardware, and so on. That's how your communication is going to primarily take place. ठीक है? इसका ये मतलब है कि I can make a direct statement that my Java application is not executing on the underlying OS. Because it is not executing on the underlying OS, my Java app is OS independent. Because my Java app is OS independent, I can also say my Java app is platform independent. Are we getting this? Java application, which is the bytecode, is not running on the operating system. Because the Java application is not running directly on the operating system, my Java app becomes OS independent, or I can also say the Java app is platform independent. However, if I look at the JVM is directly running on the operating system. Now, because my JVM is directly running on the OS, my JVM is OS dependent. ठीक है, इसका ये मतलब है विंडोज का जो JVM है ये अलग है और लिनक्स का जो JVM है ये अलग है. So for every platform I'm going to have a separate JVM. ठीक है, हर एक प्लेटफॉर्म के लिए JVM अलग अलग आएगा. For Windows also it's going to be separate, for Linux it's going to be separate, for Mac it's going to be separate, for a mobile phone it's going to be separate, and so on. So the JVM is going to be differing from platform to platform. Now I have a very simple question. After we are through with this course of 2.5 months, will you guys be able to develop a Java application? Well, obviously, yes, that's exactly why you're here, right? But after this 2.5 months, will you be able to create a JVM? Because as I said, every operating system requires a separate JVM. So tomorrow in the market, if a new JVM has been introduced, you will have to generate a JVM for that operating system. Someone will have to generate a JVM for that operating system. So my question to you is, will you be able to develop a JVM for the new OS? Come on, guys. Do you think you will be able to develop a new JVM for a new OS? Absolutely not. It's not going to be possible. It's not a single man's work, or it is not something which can be done so easily. So that's never going to be possible. Then what is it more easier? Is it more easier to create a new application for a new platform which is introduced, or is it more easier to create a new JVM for the new operating system which is being introduced? Are you getting my point? What I'm trying to say? The reason why we are talking about platform independency is because we realize that applications have to be redesigned for new platforms. नया प्लेटफॉर्म आया तो फिर से वही एप्लीकेशन मेरे को दोबारा लिखना पड़ेगा, अग्रीएबल. बट आज की डेट में अगर आप देखोगे तो डिफाइनिंग एन एप्लीकेशन is far much more easier than defining an operating system. Sorry, than defining a JVM for an operating system. So after a course of Java, you are able to develop a new Java application. There is no problem whatsoever. But you are not in the position to develop a JVM. Then why the hell are we doing all this? The answer is pretty simple. If I consider the different kind of operating systems that you have over the past years, let's start right from 1995 to probably 2015. You have seen Windows, Linux, and over these years, you have seen maybe 15 versions of each. Okay. You have Windows, you have Linux, you have Mac, you have uh, whatever, you have Solaris, and so on. So even if I consider that I have 100 odd operating systems today, if I consider that I have 100 odd operating systems today, I have to generate a JVM once for these particular operating systems. But if I consider starting from 1995 to 2015, 20 years down the line, how many lines of code have been written every day? How many applications have been created every day? I have millions and millions and trillions of applications that have been created. So what is more sensible? To convert those trillions of applications for the new platform, or just to create a new JVM whenever and however a new OS is being introduced? Are you getting my point? What I'm trying to say? By just creating a new JVM for that operating system, what assurance is he giving you? Java states to you that by creating a JVM for that new system, I assure you that any code that you have written till date and any code that you're going to be writing in the future is all going to be compatible. That's the key principle of platform independency with Java. Now, how does he manage to do this? It's a very simple principle that this guy goes ahead with. If I look at the JVM part, okay, we're specific to the JVM right now. If I look at the JVM part, the JVM simply acts as an interpreter, which has two parts to it. A part of it which is communicating with the underlying operating system. The job of this part is to convert your byte code, which is given to him in the form of the input. The byte code which is given to him in the form of the input, this has to be converted in the form of the underlying binary format for the underlying OS, whatever is there. Okay, it's something like this. Let's say you guys need to visit to France to talk to a French delegate out there. Now that guy only understands French and you only understand English. I would say rather the perfect example today would have been with our Honorable Prime Minister, Mr. Modi. He has been having n number of trips abroad. He has been visiting China, Japan, Africa, US, and stuff. And I'm pretty sure he's not able to communicate with them. So every time he's on the move, he always takes along with him a translator. If I need to go to China and I wanted to communicate with the guys in Chinese, the best thing I would do is I would take an English to Chinese translator. Whatever I say in English, the translator is supposed to translate into Chinese and communicate to the Chinese delegate. Same way, when the Chinese talk, he communicates back to me in English and the communication takes place. Tomorrow from China, if I need to go to France, obviously I cannot take the English Chinese translator, but I hire out another translator So it's going to be an English French translator. The same way the communication is going to take place. The best part I realize in this whole scenario is at any given point of time, the input which was provided was always in the form of in the form of English. The input is always in the form of English. Only that part which is to convert that into the underlying OS is what is changing. So tomorrow, even if I had to go ahead and um, I had to develop a JVM for a new OS, all that I had to modify was the latter part, because the first part of the JVM will always remain the same. And that also, when do I have to do it? Only once, when a new architecture or a new operating system has been completely introduced. And that gives me the assurance that once you have developed this new JVM, any code written prior to today and any code that is going to be written in the future is going to be compatible to this particular architecture. Are we all clear till this point? Anyone has any questions? Anything you would like to ask? Okay. Now, what do we need to understand next is uh, yes, Aditya, your question with each Java release, JVM does not update. No, that's not the fact. JVM does update. Every version is going to have something different. Let me just quickly give you this. We'll revisit this later on. So even if you all don't understand this, just ignore it, please. If I consider the bytecode today, again, the bytecode is being generated on a format. The current format which is being used for bytecodes is 60.x. The JVM release that we have, that is, I would say the JDK or the JRE release that we have, is only still working on 8.x. So technically speaking, my bytecode has been modified and it has reached to version 60x, while the JDK is only up to 8x. However, this really does not matter, Aditya, because every JVM, any new JVM, let's put it this way, any new JVM that is going to be created, no matter what modifications they do in that, it is always going to be backward compatible to the previous version. So any code that has been defined right from JDK 1.0 will be even till date compatible on this new version of JVM. Yeah, it is not forward compatible. You know what I mean? I mean, suppose I have a Java code which has been compiled with the latest compiler of JDK 8. I will not be able to run that code onto an old compiler. That is, sorry, an old VM. So I cannot run that on 4.0. But if I have any code that is designed from 1.0 to 8.0, any of this code can work on version 8.0. So I would always say the bytecode format is always backward compatible, but never forward compatible. Do I answer your question, Aditya? Deprecated methods, Nikhil, will always remain there. Okay, deprecated methods, that's exactly why these methods have not been eliminated. They have not been removed. They are marked as deprecated. So even today in version 8.0, if I'm using a method which has been marked as deprecated, the compilers will allow me to use this method because they have to maintain backward compatibility. They cannot remove that method. So it is advisable by the organization not to use these methods. But if you still want to go ahead and use them for whatever odd reasons, you can use them. Um, Now, I told you that Java came into market in 1994. This was the first version of Java which got introduced. And until the year 1999, Java never picked up in the market. Okay. Now, the reason why it never picked up in the market was due to its performance. The only problem was that everyone was trying to compare the performance of Java with C++. Now, we all know that C, C++ applications were directly running on the OS, which was running on the hardware, versus Java applications which had to run on the JVM, then the OS, and then the app. Obviously, the performance had to degrade. The second problem with Java initially was Java was, or rather even today, Java is what we can say is partly compiled and partly interpreted language. Now, what do I mean by this? We all know that after my Java code has been compiled, it generates the bytecode. Bytecode is not executable on the underlying platform. So what basically happens is my bytecode is given to the JVM, and the JVM interprets that bytecode for the underlying platform. Okay. So until 1999, which was with JDK versions 1.0, 1.1, this interpretation that was taking place was literally taking place line by line and each time. So let's say if I wanted to use a statement called as bonjour, my interpreter was picking this line, converting it to good day. And this conversion to good day was being done at every execution. Now the point was very simple. Once a bytecode has been reached to a particular platform, we know it is specific to this platform. But what Java was doing, even though the bytecode was to that particular platform, Java was again opening the entire bytecode, and in every execution, it was picking it up line by line and trying to interpret it. This degraded the performance to a greater extent. That's why, after realizing the blunder, in 1999, Java came up with 1.2. This is where a great revolution took place, and that's the time when we started calling this as Java 2. Now, what is the main revolution that took place? This guy went in with something called as a jitter. Java introduced a concept within the JVM called as a jitter, which is a just-in-time compiler. Okay? So this is termed as a just-in-time compiler. Now, what jitters used to do is once a bytecode has been given on a platform to execute, the entire bytecode would get converted to binary on the first execution and kept into a temporary folder. Every subsequent execution would pick up the binary from the temporary folder and execute it. So the performance of this drastically improved and became very equivalent to C++, though it is not comparable, but still yes, it came quite close to C++. That's exactly when the language started getting all its names as J2SE, J2EE, J2ME, and so on. These were the names which were provided to the language at that particular point of time. Over the years, Java upgraded itself. More and more new features started coming up. More and more things started getting introduced. Versions started differing, and they started coming into various kind of versions, like they came down to 1.3, 1.4. Then someone realized that okay, fine, Java 2 was a big step revolution. After that, every time it has been a big step revolution. Why are we still stuck on with that name J2SE, J2E? So they decided to eliminate that version, and from this point onwards, they started calling it 5.0, 6.0, 7.0, and currently what we are working around with is 8.0. Due to the extensive contents of Java, Java primarily bifurcated itself into three major distinct parts. The Java SE, that is the Java Standard Edition, also abbreviated as JSE. The second thing was the Java EE, that is the Java Enterprise Edition, also abbreviated as JEE. And the third thing was the Java ME, also abbreviated as the JME. Anyone knows the full form of Java ME? That's absolutely wrong. It's not the mobile edition. This is very commonly mistaken to be the mobile edition. It's the micro edition. Okay, it is not specifically designed for mobile phones, but it is designed for any kind of handheld devices. which are set-top boxes, PDAs, DVD players, Blu-ray players, and stuff like that. So it is termed as the Java Micro Edition. So three major technology bifurcations: Java SE, Java EE, Java ME. I hope you guys are making a note of all this. This is going to be quite essential for you. Okay. So you have these three technologies: Java SE, Java EE, Java ME. I would like you to take down some notes further than this. So please be prepared with a pen and a paper or whatever your books which I had asked you all to. Are you all ready for it? Okay. Now the Java SE, that is the Java Standard Edition, the Java Standard Edition comprises of all the necessary tools and APIs, comprises of all the necessary tools and APIs to define the language and develop basic applications that may be either console based, desktop based, or network based. Java SE comprises also or is bifurcated with JDK and JRE. JDK stands in for the Java Development Kit that consists of all the necessary tools that consists of all the necessary tools and APIs along with a runtime environment that is used to develop, execute, and debug, that is used to develop, execute, and debug a Java application on the underlying platform. Second, the JRE. The Java runtime environment comprises of the basic set of tools and libraries that are required to execute a Java application on the underlying platform. Okay, so we have JDK, we have JRE. JDK gives you all the tools, libraries, along with the debugger that will allow you to develop, execute, and debug a Java application, while as a JRE will only allow you to execute applications. So if you want to give your client a Java application that has been designed by you and you want him to only execute, but obviously you will only have to ask him to download the JRE. But when you are going into a development, what you would also require along with that is a JDK. Fine. The second thing that we have is a Java EE architecture, that is a Java Enterprise Edition. Please take that note down. The Java Enterprise Edition comprises of all the libraries and frameworks, comprises of all the libraries and framework along with a set of tools that are used for developing enterprise and tier based applications. Enterprise and tier based applications. N tier, multiple tiers. So N tier based applications, they comprise of various framework technologies. They comprise of various frameworks and technologies such as servlets, Java Server Pages, that is JSP, JMS, that is Java Messaging Service, JMS or Java Messaging Service, JNDI, the Java Naming and Directory Interface, Java Naming and Directory Interface, EJB, the Enterprise Java Beans, JSF, Java Server Faces, Java Mail, and so on. Finally, the third one, the Java Micro Edition, is used for the development of portable handheld devices varying from mobile phones, PDAs, set-top boxes, Blu-ray players, and so on. Okay. Now, as I told you, our primary focus is going to be on the Java SE as of now. So when you want to go ahead and develop applications which are going to be using Java SE, you would have to have the JDK and the JRE. Now, a very easy way of defining this is something like this. If I have a look at, or if I consider this as JDK, a small part of this JDK is also going to be the JRE. Because common sense, when you're developing applications in Java, you would also need to execute them. Because you need to execute them, that's exactly why the JRE has to be embedded within itself. So a JDK would always comprise of the JRE. This is a part which has been provided here. Now, how do I procure all this? So for procuring all this, I am just going to get down to a website which is oracle.com. Now, if you come down to oracle.com, in fact, I missed one step out. Uh, in 2012, Sun Microsystems was taken over by Oracle. Today, Java is a product of Oracle. Obviously, earlier it was belonging to Sun Microsystems, but there was a great deal which took place in 2012, April 2012 to be more precise, where Sun Microsystems was taken over by Oracle, and that's why Java has officially become a part of Oracle. But if you come down to the Oracle website, you can see a section called the downloads. On the download section, at the left hand side, you see popular downloads, which gives you Java for developers, Java for your computer, Java SE, Solaris, MySQL, and stuff. So you need to go down to the Java for developers option. And on this, the left hand side again gives you all those different technologies of Java. The three primary ones which I had defined to you, the Java SE, the Java EE, and the Java ME. These are the main primary things. You're already on the Java SE section, which we see, and you realize that we have the Java platform JDK 8 with U73, U74. This is your point which you were talking about. This is an update of the Java SE. Now, even after Java 8 was introduced, they have updated the virtual machine 73 to 74 times. Obviously, these would have been those different bugs and stuff which they would have noticed during that particular deployments. You also see you have another option, NetBeans with JDK. Now, NetBeans is one of the IDEs which is promoted with Java since a very long time. Though we are going to be working around with another IDE called as Eclipse. It's much popular than NetBeans in the market for a number of reasons. We'll come across with that later on. So all that I expect you all to do today after the session, please don't do it right now. After the session, what you're going to be going ahead with is you're going to go ahead and download the JDK. When you select onto the download JDK option, it's going to give you a different version or a series of versions of the JDK which you want to go ahead with. You may choose any one, update 73 or update 74. It's not really going to make much of a difference to us. The most important point which you should notice out here in this case is you have different versions for Linux, which you can see based on the architecture, whether you're working with a 32-bit architecture or a 64-bit architecture. You have a different one for Mac, you have different ones for Solaris, and finally, you have different ones for Windows. Now, depending on what operating system architecture you are using, you will have to go and choose the appropriate one. So if you're a person with a Linux fan, you need to go ahead and select the Linux option based on 32 or 64-bit architecture. We are going to be practically using Windows. Again, if you are in Windows, please identify your operating system, whether you're using a 32-bit architecture or a 64-bit architecture. Can everyone please clarify what architecture are they using? Or rather, how do we find that out? So if I wanted to check, okay, if I wanted to go ahead and check this, I could have checked that by getting into my computer, the current PC, and system properties. So when I come down to my system properties, you would notice that I have the operating system which has been mentioned out here. So if you notice, in my case, I'm using a 64-bit OS. Okay, so please everyone, ensure that you are checking onto this, whether you're using a 32 or a 64-bit, doesn't matter whatever you're working on with, as long as you know the right version that you're using. So if you're using a 64-bit architecture, as I see majority of you are doing, in that case, you would have to download the Windows x64. Okay, that's a 186 MB file which you can see out here. So what you're going to do is you're just going to click on that download link and go ahead and download that exe file. Right? So this is your first step that you're going to follow. Now, once you have downloaded this, you should get something of this sort. So you will get to see JDK which has been provided to you, which is right now I'm working with an update 20. So you will get an update 8 or sorry update 5, 20, 73, whatever you're downloading. Now, I want you to be very, very careful while you're installing this. So pay attention to what I'm saying very carefully. When you run the setup of this particular exe, when you run the setup of this exe, you are going to come to the first step, click on to next. On the second step, it is going to ask you, where do you want me to install this? Okay. Now, by default, if you notice the install location which has been provided to you is C:program files, Java, JDK 1.8.0 underscore whatever update version you may be having. I want you all to change this. So all that you have to do is you guys need to click on the change button and give the path as C:*Java SE. Okay. Now, it is not a compulsion to do something like that, or it is not that if you're not going to do this, Java is not going to work, nothing like that. The basic point is the reason why I'm telling you is we are going to be working around with the command prompt and we are going to be executing Java applications. So every time I would have to go down that entire path in order to go down to use the tools of Java, which are not going to be very practical to do. So why unnecessarily go through that entire long path? So even in my system, I have it installed on C colon Java AC. And that's exactly why I'm asking you to do the same. So if you notice, if I come down to C drive, you can see a folder by the name of Java AC, which I have. Okay, that's what I'm going to be using for all practical purposes. Now, once you have successfully set up this stage, okay, once you have successfully set up this stage, the next thing that you're going to do is just click on to next. It is going to proceed further. Now, after the next step is over, it will again ask you for a new path. Okay, please, please pay attention to this. Twice, it's going to ask you for a path. The first time, it's going to ask you for a path which is pertaining to the JDK installation. This is something which you are going to select as C colon Java SE. No spaces in between, just take it as one word. The second time when it is asking you for the installation path, it is asking for the GRE installation. This is the time when you let it be default. So whatever is the default value which has been provided, just let it be as it is. Do not, I repeat, do not again give Java SE. If you give this, what will happen? Your JDK will get deleted. And what you'll have is only GRE on your system. So I don't want something like this to take place. So what you are going to do is the first time you're going to set the path to C colon Java SE, and the second time when it asks you for the path, just leave it blank, or rather not blank, but whatever is the default value. So just leave it as it is and complete the entire setup procedure. Are we all clear till this point? Anyone has any questions? Anyone would like to ask anything? Great. Okay. So that's up with your JDK installation that you are supposed to take care of. We'll just have a short break of 10 minutes and we'll be back with developing our first basic hello world application in Java. It may happen that the uh, the training may get ended because if I don't respond for the next 10 minutes or so, it by default shuts down the training. So in case that happens, I'll be back again after 10 minutes and we'll be going ahead into developing our application. So my watch right now shows that 6:40, 6:50 is the time when I'll be back. Thank you guys. Welcome back guys. I hope we had a good short break. Yes, Raj. Yes, Raj, you had a question? Can I come again on what? Nothing, I just said welcome back. We are all ready to start off with our session. Yep, we can. Am I audible again, loud and clear to everyone? Great. So now, as we have seen, what are the prerequisites to go ahead and start developing a Java app? I have very clearly mentioned that we require the JDK kit, which has to be installed onto a system. I'm just going to show you what your JDK actually comprises of. Now, once you have installed the JDK, you would see a folder C colon Java SE on your system. When you enter into that particular folder, there are a few folders and files which are pretty important and crucial to see out here. The first thing that you have, which is pretty important, is the bin folder. This is where all your binaries reside. Now, the binaries are all those tools which are required for the development. Okay, so you have your Java compiler, you have your JVM launcher, You have other necessary tools which are going to be required to execute your app. That's something which is going to be there as a part of the bin folder. The second important folder that you have out here is a folder by the name of lib. This is the place where you will find all your jar files provided. Now, jar files are simply library files. They contain all the .class files. So whatever APIs have been provided to you by the Java language that come to you as a part of JSC, they are all going to be available in one of these jar files. You would have to separately download the API docs, which is required. I have a slightly older version, doesn't really matter. I'll do the new one pretty soon. So what you need to do is unzip that and you'll get to see a docs kind of a folder which has been provided to you. Apart from that, you also see a zip file called as SRC. It's a pretty interesting zip file. This zip file comprises of the entire source code of Java. Now, the best part is that Java as a language is an open source language. Can anyone tell me what do you mean by an open source language? Java is an open source language. What do I mean by an open source language? Yes, guys. Wow, great match. Source is open, yeah, but what do I exactly mean by saying that the source is open? Anyone with an idea as to what is an open source? No, Aditya, that's absolutely wrong. That's the answer which actually I was, uh, trying to wait for. Someone has said it's user friendly. No, Shweta, it's not user friendly. We can see source code for Java API. That's right. We can see the source code for Java API. And what benefit are we going to get with that, Raj, by seeing that? Now, the point is, as Aditya wrongly said, you can modify the code. No, you cannot modify the code. The basic principle of open source states that the code is available for you to view and understand, but not alter. That's the primary violation of open source code. If you try to alter any code of open source, it's a major violation of open source. I don't know how many of you are aware, but somewhere in the year 2001, Microsoft had introduced a new language called as VJ++, the Visual J++. And what he started doing is he started customizing the source code of Java and bringing it into its new environment. That's the time when Sun Microsystems had filed a case against Microsoft and Microsoft lost. It is only after that that Microsoft realized and he developed the .NET platform or the .NET framework. So the basic principle of open source is it is free for viewing and understanding, but not altering. Okay, so that's something what I had even out here. Even I mean the entire source code of Java has been provided to you, and you can actually venture into any of these folders and files and see what it contains. So if I go into the lang package, I'll see a series of all Java files which have been provided to me. Okay, and I can just open any one Java file and I'll be able to actually see the source code which the developers of Java have defined out there. So let me start showing you by some class functions and stuff. If you can notice out here is the actual source code which is there. But again, keep it in mind the source code is only available for you all to view and understand, not to alter. Now, if you also notice, you have a folder out here by the name of JRE. Remember, I told you the JDK comprises as a part of JRE for execution. This is that JRE. Before I can take you into that, let's go into the bin folder. In the bin folder, you will notice that the bin folder of JDK comprises of a series of tools. Basically, all EXEs that have been provided to you. I just want you to look at just two or three of them, which are going to be pretty important for us. One is the Javac, that is the Java compiler. Second is the java.exe, which is the Java launcher. Java doc, which we will be using later on, which allows me to create the documentation of Java. Applet viewer, which allows me to test applets. Java W, which allows me to run Java under the Windows platform. Java P, which is a reverse engineering tool converting bytecode into source code, and so on. So these are all those different kinds of EXEs which have been provided to me, which I can work around with. They all are very specific to the Windows platform because my JDK is for Windows. That's the reason they are also specific to the Windows platform. Similarly, if I were to go inside the JRE folder, again my JRE folder comprises of the bin and the lib. Look at the bin folder out here. They comprise of a variety of DLLs, mainly DLLs. The most important thing to notice in this case is you have an exe by the name of Java exe. That is the JVM launcher. But if you notice, you don't have any file out here, Java doc, Java C, JDB, none of these are available out here. The reason being, those tools were very specific for development. They were not required for runtime, for execution. So during runtime, you are not going to be having the compilers and stuff, and that's exactly why the JRE comprises of all those tools only, along with the library that is required for the execution of a Java application and not for development. So that's the basic structure which has been provided to you for the Java folder. Apart from this, I told you you have a folder by the name of docs which you have to separately get. You can always venture to the index.html file out there. Please have a look at the index.html, which talks about the JDK platform and the JRE platform. Again, if you notice, the JDK comprises of all these tools and APIs, which are given to you in the beginning. But the JRE lacks those tools. So the Java P, the Java C, the Java doc, the jar, the JPDA, JConsole, and so on. All this is missing as far as the JRE is concerned, and the JRE comprises of the main VM, that is the virtual machine, along with all the other APIs that would be required to execute any Java application for the underlying platform. Please note, both the JRE and JDK are platform specific. That means for every platform, you have them different. You have to download different versions of JDK and JRE. Now, let's carry on to our next level. And what we need to get going with is we need to go ahead and develop our first Hello World application in Java. So to do this, I'm going to be using your favorite editor, which is going to be Notepad. As far as today's session is concerned, we are only going to be using Notepad. When you talk about console, it means a typical console, a character input, somewhere where you're going to take input and output in the form of characters. There's going to be no graphics involved out there. This is what a console refers to. So when I come down to the command prompt, a command prompt is a perfect example of a console which has been provided to you. Okay. Like for example, Shweta, if you are connecting to a Linux machine, okay, what you get is a Linux prompt. The Linux prompt is known as a Linux console. So that's the place where you can fire your Linux commands and work around with it. The same way, in case of DOS, we have the command prompt or the DOS console, which you see right in front of you, which is popped out. Okay, so they are always going to give you outputs in the form of characters. Now, what I'm going to do out here is I'm going to simply develop a Hello World application using Notepad as I stated. Now, you remember yesterday I had told you all that you have primarily three types of languages that we can refer to. Okay, one, you have something that we call as an object-based language, and I've given you an example which was Visual Basic for this. Second, you have something what we call as a object-oriented programming language, and the example perfect for this was C++. And an advancement of the object-oriented was a 100% object-oriented programming language, which we have also referred to. I had given you three rules to be qualified for a 100% object-oriented programming language. What were they? Three rules I had indicated to you all. Any language will be a 100% object-oriented language provided it follows these three rules. A, nothing global. That means everything has to be encapsulated within a class. B, all features, that is major features of hooks to be followed. So all these features have to be supported by my language. And third, everything to be treated as an object. These were the basic three features that we had discussed about, which will qualify any programming language to be a 100% object-oriented programming language. Now we all know that Java is not a 100% object-oriented programming language because it has support for primitive data types. It does not treat everything in the form of an object. So it does not have support for primitive data. I mean, it has support for primitive data types and lacks the feature of 100% object-oriented, but it is pretty close to being 100% object-oriented. And there is a way you can even create your programs 100% oops. Now, because Java is quite close to 100% object-oriented, it follows the basic principle. Now, Java states that whenever you define even the entry point of an application, this entry point cannot be global. Nothing in Java is global. You cannot have variables global in Java. You cannot have functions global in Java. Everything has to be encapsulated within a class. Now, for doing this, I am going to primarily go ahead and define a class in Java. It's defined the same way as you would define it in C++. So, sorry, in C++. So here I'm going to define a class called as entry. You may or may not terminate it with a semicolon at the end. So it is not mandatory that you need to have a semicolon at the end. You may or may not have it. So I'm just going to say this is going to be class entry, open and close curly braces. Now the entry point to an application in Java is given to you as a public static void main function that takes in an argument in the form of string args. Okay, this is a standard format of defining a entry point within your Java application. So the function is a public function. That means it's accessible to the whole world. It's a static function, which means that no one has to create an object of the entry to invoke this method. The return type I've given as void. The name of the function is main, highly case sensitive. Java is a case and spelling sensitive language. And these are the command line arguments that one would like to pass to the function. The string is capital. It's a capital S which I'm using out here. So it's a string args. Now either you can write it as string subscript args or you could have said string args subscript. It doesn't matter. It's one and the same thing. It's basically indicating that I'm taking an array of strings. Okay. So you have the public static void main string args which has been provided to you as the input. Going on further down, I want to go ahead and print an output on the console. So I'm just going to make a statement out here. System. Now the system is a class provided to you in Java which refers to the underlying JVM. This is the statement you pick it up for the time being. So system refers to the underlying JVM. Or out. Out is a static object which is used for outputting. Now it's very similar to C++. If you notice, C++ used to use something called a cout, which was a global object. Instead of that, Java has got an object called as the out, which is encapsulated within the system class. The reason why I can directly access it like this is because it's a static variable, which in turn comprises of a function called as println, print with a new line, and I'm going to give it out there as hello world semicolon. So syntactically, if you look at it, it's more close to C++. Okay. The primary difference which you see in this and C++ is something like this. C++, I have a class called as entry. I would have said something like public colon and then start defining all my functions, whatever I have. Or I would have had something like void fn, declare it out here, close this, carry on further, scope resolution, fn, and then define the body. ऐसा C++ में चलता है, जावा में ये नहीं चलता है. जावा में जो भी फंक्शंस आप डिफाइन करोगे वो सिर्फ और सिर्फ क्लास के अंदर होगा. ठीक है. 1. Secondly, Java के अंदर हर एक statement जो आपका जाता है, that is whether you're defining a function or a variable, it has to be preceded with an access specifier. So I cannot just give like public can carry on for everything to be public. It is not possible. For each and every declaration, I need to have its own access specifier. Okay, till here? Does anyone have any questions so far? Cool. Now, my question for you is this. I have defined a class called as entry. I know that this has to be saved into a file. Every Java class that I define should be stored into a file with an extension .java. After this is compiled, it will generate a bytecode which will give me the extension of the file as .class. My question to you is, what should be the name of this file which I have created? What do I provide as the name of this Java file that I have created for the class entry? Okay, Prerna, it's entry.java. Shweta agrees to entry.java. Can I have any other name apart from entry? Well, I can. So what I'm going to do is, I'm going to save this file. I'm going to save this file into Java online folder. Okay, and I'm going to give this file name as anything.java. That's the name of the file that I'm going to put up out here. And I'm going to save that file. So I have a class defined as entry, which is defined inside a file called as anything.java. Now it is the point of compiling this code. I'm just going to be pausing your screen for a second just to do some setting. So just hold on for a minute. Now, since I am not using any IDE at the moment, I am going to be using the command prompt to compile this code. My file anything.java has been stored in E drive. So I go down to E drive Java online folder, and if you look at it, I have a file out there which is called as anything.java. Now, if you remember, I told you that Java or the JDK comprises of the compiler which is called as a Java C. So what I'm going to do out here is I'm going to use the compiler Java C space anything.java, and I give an enter. Can anyone help me out with this error? Javac is not recognized as an internal or external command, operable program, or batch file. What path are you talking about, Prerna? The path should be set. Path should be set for what? Okay. The basic point now is very simple. Whenever we look at any kind of tool that we want to use, guys, please pay attention to this. Whenever we want to use any exe from the console, okay, the location of this exe should be known. Now, by default, what is my console doing is my console is trying to look for java c.exe in a folder by the name of Java Online. Obviously, the Java Online folder does not contain the exe called as Java C. Because there is no such exe called as Java C, that's why he gives me an error out here. Okay, let's do one thing. Let's come down to C colon to the folder cd java se cd bin. If you remember, this was the location that was containing my exe file. So just for your information, I'm just going to say directory for that, and you notice that Java C is out here. So if I make a statement Java C, it works perfectly great. The reason being, by default, whenever you execute any command, the command will try to be located in the current folder from where the command has been executed. So since I'm running the command in the bin folder, he will try to locate it out there. If it is found, fantastic. In fact, even if I go one folder up and I try to run it, it will give me the same error. Now, every time it is not possible for me to go down to that specific folder in order to run my command. Okay. So what I get as an option is I can go ahead and set an environment variable called as path. This is given to me by my command prompt, or I would say this is also given to me by my OS. Now, path is a variable which I can set, which can tell the command prompt the different possible locations where he should look for an exe before giving any error. So let's say if I have set the path to C colon Java semicolon C colon test semicolon C colon Java SE backslash bin semicolon and so on. Whenever I run the command Java C, the very first thing this guy will do is he will try to check in the current folder. Do I have Java C? No. Go to C colon Java. Do I have Java C? No. Go to test. Do I have that? No. Go to Java SE bin. Do I have it out here? Yes. Since the file has been located in this folder, go ahead and execute that. So the environment will try to search through all these paths that have been defined to locate the exe. In case, for any reason, if it does not find any one of the paths, for whatever reason it may be, that if you've defined a wrong path or whatever, and it does not find in any one of the paths, it's simply going to give you the error, unable to locate that particular exe. So unrecognized command or whatever is the error which is going to be setting up. Now, if you notice, my current value of the path is null, it's blank. So what I'm going to do is I'm going to put a statement set path is equal to C colon Java SE backslash bin semicolon percent path percent. Now this percent path percent is very important. Okay. What does this do? If I just say path is equal to C colon Java SE bin semicolon, this will override the existing path variable. So whatever directories have been set previously in this path variable, they will get destroyed. The entry will get destroyed, and you'll have only this path out there. That means your Java C will work, but maybe other applications will fail to work. By putting up the percent path percent at the end, I'm telling him that after you set this path, whatever was the value of the original path, I want you to append it at the end. This point, in short, it's concatenation. Okay? I'll give you an example so you'll understand it better. सबसे पहले हम लोग ये पाथ सेट कर लेते हैं. Now I say Java C. My Java C is working from E drive also, if you notice. So if I say Java C anything dot Java, you notice my code compiled successfully. Okay. This was the basic idea of the path variable. Now again I say path is equal to, or set path is equal to C colon test semicolon. Look at the path variable. The path variable only contains test. So my original path which was there has been lost. So again I'm going to say set path is equal to C colon Java SE backslash bin semicolon percent path percent. Now when I have a look at my path, I have my C colon Java SE bin set and plus the new path has come up. Set path is equal to E colon Java semicolon percent path percent. Again have a look at the path. So basically every time I'm saying percent path percent, it is simply appending to the path. So this resolves one issue of mine by setting the path. I would like everyone to please take down this command. It is set path C colon Java SE backslash bin semicolon percent path percent. Okay. Now the second point is that after you have set this path is only going to be valid for the current instance of the command prompt. Which means if I exit from here and I start a new command prompt instance, the path variable will be completely different. Okay. So if I just say set path is equal to semicolon, you'll realize that my path does not contain anything, or if I don't say that, then I get some default path which is a huge long value. In order to ensure that my path is permanent and I don't have to set it with every command prompt instance, please make sure your command prompt set loads, and then you come down to my computer, go down to system properties. Under your system properties, you have an option called as advanced system settings. Enter into advanced system settings where you see the environment variables. Come down to environment variables. Now, under the environment variables, you primarily have two environment variables. One is a user variable and one is a system variable. The user variable is only valid for the current user logged in my case, by the username Frankel's Infotech. So it will be only visible to this user. If another username is on the machine and someone logs in with that name, these variables will not be accessible to him. He will have his own set of variables. The system variable, on the other hand, is applicable for everyone. It is for the entire system. Now coming down to the system variable, again you will notice there is a variable by the name of path. If I edit that, please be very careful while editing it off. Depending on your OS, this will be differently given to you. The look and feel will be different. This is how it shows you in Windows 10. Otherwise, the other one has a simple text box where you need to alter it. So please be careful of not removing the previous values, whatever are there. In my case, if you notice, I have the entry of C:\Java AC bin which has been provided to me. Okay, and this is the reason why when I launch the command prompt, I get to see the value coming up as a second entry. So any setting that you have done in the environment variable is going to be a permanent entry. It's going to be there always with each command prompt instance that you have. I'm repeating as to how do we get down to that. So for doing this, you're going to go down into my computer. You're going to enter into system properties. Under your system properties, go into advanced system settings. Under that, you have an option called as environment variables. In the environment variables, you will come down to path, edit, and add an entry out here. So all that you have to do is just say new entry and just give him whatever path you want to specify. Also, please ensure that when you're giving this new entry, your Java AC bin has to be on top. Okay, don't put it at the bottom. The reason for that is very simple. There would be other applications on your system which also come with JREs. Okay, like initially Oracle used to always come with JRE. Now, if the Oracle JRE, like you can see out here, program data, Oracle, Java, Java path. Now, if this is prior to your Java AC bin, so let's assume it is somewhere out here, then this version, whatever has been supplied by Oracle, will be taken up in your case, and that will be an older version. You have to always ensure that your Java path is much prior to any of the other Java paths that are going to be available out. Are we all clear till this point? Great. Now, once I have done this, I'm reverting back to my command prompt, cd java online, java c, anything dot java. If it comes down to the next command prompt, that means your code is free of compilation errors. Obviously, you don't have any kind of compilation errors in your code. All that you need to do is run. Now, before running, I'm just going to check the dir. Very importantly, please notice the .class file which has been generated. Irrespective of the name of the Java file, the .class file which has been generated is based on your class name. So what you get to see out here is you have a file which has been created by the name of entry.class. I'm repeating, irrespective of the name of the Java file name, the .class file which gets generated is for your class name. So since I had a class called as entry I have a corresponding .class file, which is the bytecode called as the entry.class. Now I need to go ahead and execute that, and to perform that task, I'm simply going to use the command Java. Let me just do the screen. So I'm just going to say Java followed by the name of the class. No extension to be provided out here. I just say Java space entry, and what I get is a simple output as hello world. Okay. Now I have a small question to you all. Can one single Java file comprise of multiple classes? Great. Yes, it can. Can one single Java file comprise of multiple classes, and each of these classes containing an entry point as the main function? I'll repeat my question. Can a single Java file comprise of multiple classes, and each class contains the entry point as the main function? The rest would like to take a guess on this? Well, the best part is it's very much possible. So let's have another class being defined out here called a second entry. This second entry also has a public static void main function string args, and it says system.out.println hello second, and I'm going to have one final class called as the third entry, and this is going to give me the output as hello third. Will this code compile? Yes or no? Quick. Come on, guys. Will this code compile? Y or N? Hurry up. You're going with my confidence. It looks like it. Okay, so what I'm going to do now is I'm going to make a statement out here. Java, anything but Java. Wow, it compiles. And what do I get as a resultant output? I get to see three different .class files. Second entry.class, third entry.class, entry.class. So my code has compiled successfully. Fantastic. Now my question to you is, which main function will be fired? I have three names. Which main is going to be fired? Absolutely right. Depending on the class we call. No, Ankush. No. No, Raj. No, Ankush. It's not entry or one. It depends on what you're calling. So if I say Java entry, hello world. If I say Java second entry, hello second. If I say Java third entry, it's hello third. Obviously, it does not make sense of having a single application with three entry points. It has no meaning to do something like this, but this is a possibility one can have, and there are practical uses of this also at times, which we have seen. However, there is also one more thing that we can do along with this. Why not invoke all three of them? So what I could have done is in my main class entry, after I say hello world, I make a call to second entry.main passing in the arguments. And I say third entry.main passing in the arguments respectively. I come back to my command prompt. I'm going to recompile the file. This is very important. I'm going to recompile the Java file, and I say Java entry. Obviously, I'm sure everyone can guess by now what should be the output. So the output is going to be hello world, second entry, or hello second, and hello third. I get all the three outputs delivered to me. Is everyone clear till this point? Any questions? Any doubts? Anything you wish to ask so far? So that's something what we have that we could have worked around with. Okay, we are going to stop here for today. This is all what I want you all to go ahead with and just see at the basic Hello World application. You have the entire week to download your JDK, your JRE, sorry, your JDK primarily. Please also ensure that you have downloaded Eclipse and kept it ready for the next week. Next week, you're going to have a full-fledged session of 3.5 to 4 hours, and we're going to cover a lot of things. Now, in the next weekend, hopefully, you would literally be completed with the entire language part of Java. Okay, there are a lot of things which I'm not going to be covering for you as a part of the language, like how to define for loops, how to define while loops, switch case statements, how to define if conditions and stuff, because they are all exactly the same as C++ or C. Only where there are changes, we are going to be discussing about those changes uh, as and when required. There is going to be a lot of comparison between versions also. So right from version 1.4, 6, and 8, there have been new features which have been adapted and introduced. We are going to be talking about all those things also uh, once we reach that particular topic. Uh, Next lecture, what I'm going to take you through is I'm going to show you how to accept input from the command line and process that. We are going to see the same application of Hello World and stuff in the Eclipse editor. I'll give you a briefing of the Eclipse editor. Apart from that, I am going to go ahead with various data types in Java, uh, their sizes and stuff. We are going to go ahead with taking the first input from the console and developing our first assignment as a calculator assignment. So this is all what we are going to be covering on next Saturday. Apart from that, I would also take you into concepts of strings and stuff like that. And Sunday will be more for your language, which will cover all those various keywords of the language by defining virtual functions or how to override functions, how to use abstract, how to use final and stuff like that. And I will be giving you your first major assignment, which will be a data application. So your assignment will start off from next week, and hopefully next Saturday in your materials list you would get a PDF file which would comprise of approximately 30 odd assignments which you need to take care of during the entire session. So that's something which you'll have to be submitting every now and then as and how it goes. So I guess that's all for the day. If you'll have any questions, I'm here for you all to file those out. Else I'll be catching up with you all next Saturday. All those who have not done, all those who have not completed the balance 40% payment, please ensure that this week you're completing that off. I have already sent you a mail with the bank details, so you can just do a NEFT, and I should see you again on next Saturday. So I'm here for the next 5 minutes. If anyone wants to ask any questions, sure, Raj.